Okay, so here we have this kind of dark old book here. It's got this pretty border around the edge here, this sort of floral design. It's also got kind of two borders there. And this is Cosmos, A Description of the Universe by Alexander von Humboldt. And this is volume 3. And this is an English translation since the original is in German. And that same border is on the back there. So I'm opening up, and you can see these pages with how old this book is. These pages are pretty weathered. These first few flyleaves there. And then we've got the title page. So here we see the title, Cosmos, a sketch or a physical description of the universe, by Alexander von Humboldt, translated from the German by E.C. Otte. And then we have a Latin quote from Pliny's Natural History there. And then we have a note that it's a volume 3 as well. And down here we have a publisher's note, and we can see the year it was published, which is 1858. So this is a very old book. And here's the table of contents for this volume. So contents of Volume 3, Introduction, a historical review of the attempts made with the object of considering the phenomena of the universe as a unity of nature, and then special results of observations in the domain of cosmical phenomena, uranological portion of the physical description of the world, astrognosy, the realms of space and conjectures regarding that which appear to occupy the space intervening between the heavenly bodies, natural and telescopic vision, scintillation of the stars, velocity of light, results of photometry. It's got number, distribution, and color of the fixed stars, stellar masses, stellar swarms, the Milky Way interspersed with a few nebulous spots, new stars and stars that have vanished, variable stars whose recurring periods have been determined, variations in the intensity of the light of stars whose periodicity is as yet uninvestigated, proper motion of the fixed stars, problematical existence of dark cosmical bodies, parallax, measured distances of some of the fixed stars, doubts as to the assumption of a central body for the whole sidereal heavens, multiple or double stars, their number and reciprocal distances, period of revolution, and so on there. And then there's a series of tables, it looks like, listed in this book as well. Alright, and then here is the first part, the special results of observation in the domain of cosmical phenomena, an introduction, in accordance with the object I have proposed to myself, and which, as far as my own powers and the present state of science permit, I have regarded as not unattainable. I have, in the preceding volumes of Cosmos, considered nature in a twofold point of view. In the first place, I have endeavored to present her in the pure objectiveness of external phenomena, and secondly, as the reflection of the image impressed by the senses upon the inner man, that is, upon his ideas and feelings. The external world of phenomena has been delineated under the scientific form of a general picture of nature in her two great spheres, the uranological and the telluric or terrestrial. This delineation begins with the stars, which glimmer amid nebulae in the remotest realms of space, and passing from our planetary system to the vegetable covering of the earth, descends to the minutest organisms which float in the atmosphere and are invisible to the naked eye, in order to give due prominence to the consideration of the existence of one common bond encircling the whole organic world, of the control of eternal laws, and of the causal connection, as far as yet known to us, of whole groups of phenomena. It was necessary to avoid the accumulation of isolated facts. So, pretty dense, but interesting. There is some what reads as sexist language these days, referring to humanity as just man and nature as her and those sorts of things. Let's see here. Just sort of flipping through, trying to find interesting sections. There's a section here for the velocity of light. So let's see. emphysophysicist, distinguished alike for his great acquirements and for the delicacy of his experiments, has submitted the velocity of light to a terrestrial measurement by means of an ingeniously constructed apparatus in which artificial light resembling stellar light, generated from oxygen and hydrogen, is made to pass back by means of a mirror between Suresnes and Le Butte-Montmartre over a distance of 28,321 feet to the same point from which it emanated. A disc having 720 teeth, which made 12.6 rotations in a second, alternately obscured the ray of light and allowed it to be seen between the teeth on the margin. It was supposed from the marking of a counter, compteur, that the artificial light traversed 56,642 feet, or the distance to and from the stations, in 1/18,000th part of a second, whence we obtain a velocity of 191,460 miles in a second. This result, therefore, approximates most closely to Delambre's, which was 189,173 miles, as obtained from Jupiter's satellites. Pretty interesting history there about determining the velocity of light and what kind of tools were used to do that. And there's some other, there's a lot of really rich information in here. So let's see, here's another section. It says the first catalog of the stars, which appeared after the epoch when Morin and Gascoigne taught us to combine telescopes with measuring instruments, was that of the southern stars compiled by Halley. It was the result of a short residence at St. Helena in the years 1677 and 1678, but singularly enough does not contain any determinations below the 6th magnitude. Flamsteed had indeed begun his great star atlas at an earlier period, but the work of this celebrated observer did not appear until 1712. It was succeeded by Bradley's observations from 1750 to 1762, which led to the discovery of aberration and nutation, and have been rendered celebrated by the Fundamenta Astronomiae of our countryman Bessel, 1818, and by the stellar catalogues of Lacaille, Tobias Meyer, Cagnoli, Piazzi, Zach, Pond, Taylor, Groombridge, Argelander, Airy, Brisbane, and Rumker. I'm sure I mispronounced quite a few of those words, but just an interesting history of star catalogs there. And then here we have a section for new stars and stars that have vanished. So here it says, new stars. The appearance of hitherto unseen stars in the vault of heaven, especially the sudden appearance of strongly scintillating stars of the first magnitude, is an occurrence in the realms of space which has ever excited astonishment. This astonishment is the greater in proportion as such an event as the sudden manifestation of what was before invisible, but which nevertheless is supposed to have previously existed, is one of the very rarest phenomena in nature. While in the 3 centuries from 1500 to 1800, as many as 42 comets visible to the naked eye have appeared to the inhabitants of the northern hemisphere, on an average 14 in every 100 years. Only 8 new stars have been observed throughout the same period. And it says the rarity of the latter becomes still more striking when you extend it to longer periods, I think it said there. And then here's a section for stars that have disappeared. The observation and enumeration of stars that have disappeared is of importance for discovering the great number of small planets which probably belong to our solar system. Notwithstanding, however, the great accuracy of the catalogued positions of telescopic fixed stars and of modern star maps, the certainty of conviction that a star in the heavens has actually disappeared since a certain epoch can only be arrived at with great caution. Errors of actual observation, of reduction, and of the press often disfigure the very best catalogues. The disappearance of a heavenly body from the place in which it had before been distinctly seen may be the result of its own motion as much as of any such diminution of its photometric process, whether on its surface or in its photosphere, as would render the waves of light too weak to excite our organs of sight. What we no longer see is not necessarily annihilated. And it says the idea of destruction and combustion as applied to disappearing stars belongs to the age of Tycho Brahe, and even Pliny, in the fine passage where he is speaking of Hipparchus, makes it a question, stellae an auberent nascerenturve, and you can see there was a typo with a it there. It left out the T. And so here's a table of variable stars, and it's got the names of their discoverers on the right there. And there's some other tables here as well. So this is another table showing, it looks like, let's see here. This is showing parallax and then the name of the observer. And so we're pretty close to the end here. This is sort of the last table in the book. It shows the elements of the orbits of double stars. And it shows their eccentricity and period of revolution in years, and then the person who calculated it on the right there. So then we have this index at the back, and that's sort of the whole volume there. Okay, so that was Cosmos Volume 3 by Alexander von Humboldt. Just a pretty old scientific book there from the 1850s. All right, thanks so much for watching. Bye.